Namaskar, I'm Harpreet Kaur and I welcome you all to our special live and interactive webinar series Listening to Learn. जी हाँ, सुने, सीखने और समझने के लिए. So ये जो आज का हमारा सेशन है, ये हमारा 85th एडिशन है या फिर सेशन है अंडर दिस वंडरफुल सीरीज, जहाँ पर हम आपके लिए लेकर आते हैं वाइड वैरायटी ऑफ टॉपिक्स एंड सम eminent personalities from different fields. और आज का जो हमारा सेशन है, it's going to be really interesting because topic ही ऐसा है, something that most of us have studied in a science class during our school days. जी हाँ, आज का हमारा टॉपिक है बहुत ही special and it is elementary and a story of elements and the periodic table. Yes, I'm repeating the topic for you. It is elementary, a story of elements and the periodic table. यानी तत्वों और आवर्त सारणी की कहानी, एक सरल वार्ता. अब ये वार्ता बहुत सरल होने वाली है और बहुत इंटरेस्टिंग चीज़ें हम इसमें सीखने और समझने वाले हैं. लेकिन उससे पहले मैं आपको बता दूं that you're watching us live on our e-Vidya channels 9, 10, 11 and 12 and also on our YouTube channel NCERT Official. Since this session is live and interactive, you can always call us and the phone number is 8800440559. It's flashing on your screen as well. For any other query, feedback or suggestion, you can always write an email to us. The email ID is dth.class9@ciet.nic.in. एंड लास्ट बट नॉट द लीस्ट, क्योंकि इस वक्त आप हमें देख रहे हैं लाइव हमारे यूट्यूब चैनल NCERT ऑफिशियल पर, तो आप लाइव चैट बॉक्स में जाके भी अपने क्वेश्चंस, सजेशंस, आपको कोई भी फीडबैक है तो वो आप हमारे साथ शेयर कर सकते हैं. तो आज का जो सेशन है, ऑफ कोर्स हम समझेंगे इसे लेमैन टर्म्स में और बहुत ही इंटरेस्टिंग होगा कि कैसे हम इसे एक सरल वार्ता के रूप में समझ सकते हैं और किस तरीके से ये रेलेवेंट है हम सबकी ज़िंदगी में. तो आज इस सेशन के लिए हमने स्टूडियो में इनवाइट किया है हमारे दो गेस्ट को. डेफिनेटली हम आपको उनसे ज़रूर मिलवाएंगे, लेकिन सबसे पहले मैं आपको मिलवाती हूँ, इंट्रोड्यूस कराती हूँ, with the man who is behind this entire initiative, this wonderful series that we are going to witness or we have been witnessing for so long. जी हाँ, हमारे साथ हैं डॉक्टर गगन गुप्ता फ्रॉम DESM NCERT. नमस्कार सर, स्वागत है आपका.
नमस्ते हरप्रीत
जी. और इससे पहले कि सर इस कॉन्वर्सेशन को कैरी फॉरवर्ड करें, एक और बहुत इंपॉर्टेंट चीज़ मैं आप सबको बताना चाहूँगी कि ये जो ब्यूटीफुल इनिशिएटिव है, ये आप तक पहुँचाया जा रहा है फ्रॉम डिपार्टमेंट ऑफ एजुकेशन इन साइंस एंड मैथ्स NCERT के द्वारा. और अब हम इस सेशन में आगे बढ़ते हैं और इस एडिशन में क्या खास है, सर मैं आपसे रिक्वेस्ट करूँगी प्लीज़ हमें बताएं, हमारे व्यूअर्स को बताएं.
थैंक यू हरप्रीत एंड नमस्कार दोस्तों. आज एक बार फिर से मैं आपके सामने हूँ हमारे नए एपिसोड के साथ. 85वां एपिसोड है आज हमारा. दोस्तों, अगस्त 2021 में जब कोविड काल चल रहा था, तब हमने इस प्रोग्राम को CSIR इंडिया और नेशनल ह्यूमन राइट कमीशन इंडिया के कोलैबोरेशन में इस प्रोग्राम को शुरू किया था. हमें नहीं पता था कि हम इतना आगे तक चल पाएंगे. आपके सुझाव हमें लगातार मिलते रहे, आपके आशीर्वाद हमें मिलता रहा और हम आज 85वें एपिसोड पर हैं. आगे आने वाले एपिसोड की भी भूमिका बन चुकी है. हम लगातार आपके साथ हैं. आप अपने सुझाव हमें देते रहिए, अपने टॉपिक्स हमें बताते रहिए, किन विषयों पर आप हमसे चर्चा करना चाहते हैं बताते रहिए. हमने बात कर चुके हैं इसमें हेल्थ से जुड़े हुए विषयों पर, स्पेस से जुड़े हुए विषयों पर. हमने स्पेस से जब बात की तो हमने साथ साथ स्पेस जंक पर भी बात की कि वहाँ पर स्पेस में कितना जंक इकट्ठा हो रहा है, उसको कैसे हटाया जाए, उसके साथ कैसे मिटिगेट करें, उस पर भी बात की. हमने इंडियाज स्पेस प्रोग्राम, इंडियाज न्यूक्लियर प्रोग्राम्स, इंडियाज आर्मीज प्रोग्राम, नेवल प्रोग्राम, इन सब पर बात की. आज हम एक मौलिक विषय पर आपके सामने हैं, एक मूलभूत विषय पर हम आपके सामने हैं, द स्टोरी ऑफ एलिमेंट्स. मैं उसको शॉर्ट में कहना चाहूँगा, द स्टोरी ऑफ एलिमेंट्स, कि एलिमेंट्स किस तरह से आगे खोजे गए, किस तरह से नए नए एलिमेंट्स बनाए गए, किस तरह से अब आज के समय में हमारी कोशिश है कि अपनी ज़रूरत के हिसाब से, अपनी आवश्यकता के हिसाब से एलिमेंट्स को हम नए नए एलिमेंट्स का सृजन कर सकें या नए नए एलिमेंट्स की डिस्कवरी और खोज के लिए एक हमें दिशा मिल सके. तो आज मेरे साथ हैं बहुत ही इम्पोर्टेंट और बहुत ही ख़ास इस देश के बड़े वैज्ञानिक और हमारे अपने साथी प्रोफेसर उदय मैत्रा, जो कि इंडियन इंस्टीट्यूट ऑफ साइंस, भारतीय विज्ञान संस्थान से हैं. सर, आपका बहुत बहुत स्वागत है और हम स्वागत करते हैं प्रोफेसर मैत्रा का और हम धन्यवाद करते हैं प्रोफेसर मैत्रा का कि उन्होंने हमारे साथ NCERT के साथ इस कार्यक्रम के लिए, अपना कोलैबोरेशन के लिए हामी भरी। हम साथ साथ आभारी हैं इंडियन इंस्टीट्यूट ऑफ साइंस बेंगलोर के भी, जिनका कि हमें लगातार एक सतत रूप से साथ मिलता रहा है और आगे आने वाले दिनों में भी हमें भारतीय विज्ञान संस्थान इंडियन इंस्टीट्यूट ऑफ साइंस का साथ लगातार हमें मिलेगा, ऐसी हमारा पूरा विश्वास है। थोड़े दिनों बाद हमारे साथ वहाँ से प्रोफेसर उमेश वार्ष्णेय भी हमारे साथ जुड़ेंगे, जो कि हमें मॉलिक्यूलर बायोलॉजी पर बात बताएंगे। और लगातार हमारे पिछले भी कई सारे एपिसोड्स इंडियन इंस्टीट्यूट ऑफ साइंस के साथ साथ हमारे कोलैबोरेशन में हुए हैं। एक बार पुनः प्रोफेसर मैत्रा, आपका स्वागत है। और भारतीय विज्ञान संस्थान बेंगलोर के हम बहुत आभारी हैं कि लगातार हमें उनका साथ मिल रहा है। साथियों, अब मैं आप इससे पहले कि प्रोफेसर मैत्रा अपनी बात शुरू करें और हमें एलिमेंट्स के बारे में बताएं, मैं आपकी मुलाकात कराना चाहता हूं प्रोफेसर मैत्रा से। प्रोफेसर मैत्रा एनसीईआरटी से बहुत लंबे समय से जुड़े हुए हैं और अब हमें ऐसा लगता है कि जैसे प्रोफेसर मैत्रा एक हमारे अपने ही साथी हैं। हम प्रोफेसर मैत्रा जितने इंडियन इंस्टीट्यूट ऑफ साइंस के हैं उतने ही एनसीईआरटी न्यू दिल्ली के भी हैं। और प्रोफेसर मैत्रा completed his BSc from the Presidency College, Calcutta, which is now known as the Presidency University, Kolkata, and he did his MSc from the Indian Institute of Technology, Kanpur. Professor Maitra received his MPhil and PhD from the Columbia University, New York in 1986 and while working with Professor Ronald Breslow. Following a postdoctoral stay at the University of California at Berkeley with Professor Paul Barre, he returned to India and after a year at the Indian Institute of Technology, Kanpur, moved to the Indian Institute of Science, Bangalore in 1989. Professor Maitra is presently an honorary professor in the Department of Organic Chemistry at Indian Institute of Science. The research interests of Professor Maitra include the chemistry of bile acids, hydrogels, metallohydrogels and organogels, inorganic hybrid materials, photoluminescent sensors, etc. His group has recently developed a general strategy for low cost paper based photoluminescent sensors for enzymes, certain drugs and natural products, and of course for biorelevant small molecules. Professor Maitra has also developed a small handheld device for recording and quantifying the photoluminescence from such paper discs. Dr. Maitra is greatly interested in chemistry education and is a regular participant in a variety of outreach programs for high school and undergraduate students. This is where Professor Maitra is associated with the NCERT as well. Presently, Professor Maitra is chairing the curriculum area group in science and chemistry section of the NCERT, which has been associated for the development of new curricular material. Professor Maitra frequently runs a chemistry is fun show in various locations in India and outside. Professor Maitra has received several awards, most prestigiously the Shanti Sarup Bhatnagar Award in Chemical Sciences in 2001. Professor Maitra is an elected fellow of the Indian Academy of Sciences, Bengaluru and the Indian National Science Academy, New Delhi. He is a titular member of the Committee on Chemistry Education of the International Union of Pure and Applied Chemistry, popularly called IUPAC. He is the current president of the Chemical Research Society of India. Once again, welcome Professor Maitra to our show, to our program. Friends, all the pictures which are being shown today in the session which Professor Maitra is going to take either belongs to him or to the open sources. So, Professor Maitra, it is all yours now.
Thank you. Thank you very much, Professor Gupta, for the very generous introduction. I would also like to thank you and NCERT for giving me an opportunity to share with the audience some thoughts. Hello and welcome audience to this program. It is Elementary, a story of elements and periodic table. Before I begin, I would like to inform you that every day in the history of science, in the history of chemistry, something interesting has happened. In case your birthday is today, you would like to know that you shared it with a very important event that happened in 1945, the first microscopic amounts of the radioactive element americium, element 95, was discovered in University of Chicago. 2 Nobel laureates were born on this day. Robert Robinson, who was an organic chemist, he was born in 1886, he got the Nobel Prize in 1947. And then another organic chemist, Leopold Ruzicka, was born in 1887 and he got the Nobel Prize in 1939. So, in case your birthday is today, you have many reasons to celebrate again. I would like to thank a couple of my colleagues, Professor Syam Sengupta, Professor Mukesh, who had contributed some of the slides that I am using today. I would like to start by saying chemistry is everywhere. People, the students of your age, you are always excited by these planetary missions. We had our own Gaganyaan that is going to be up in the air soon, and we have the 3rd moon landing that happened not too early, just a few months ago. Now, it takes a lot of physics and a lot of engineering to take the spacecraft to another location in the solar system. But did you ever wonder what are the reasons for which these spacecrafts are sent there? In fact, you will be surprised that the main purpose of all these space missions is to carry out chemistry on other planets. What you see here is July 1997 on Mars. This instrument, it is a rover, it is placing a spectrometer against this rock. And what did it find? It found the existence of these elements on the Mars surface, on the rock. And you can see that these various elements are shown here, and a lot of iron, which gives the characteristic red color to this planet, which we call red planet. Now, let us move forward by several more years and talk about the Cassini spacecraft, which went to Saturn towards the turn of the century. Now, I will not talk about Cassini, but I will talk about this equipment that is shown here called the Huygens probe. If you look at this probe, which was sent to the moon of Saturn called Titan, Titan is completely invisible from outside. However, this instrument or this probe was sent to the Titan, and before it crash landed, it took a picture which is shown on the right side. But then what you notice here is that at the center of this instrument is a equipment called gas chromatograph, which is a chemical instrument which measured the composition of the air or the atmosphere before it crash landed on the surface of Titan. Okay, so we move forward, and I will now move forward to 1840s, and this is a story about Mendeleev, and we will begin with Mendeleev and we will end with Mendeleev and the story of the periodic table. Here is a cartoon diagram. I would like to begin with this. Here you see parents are watching young Mendeleev placing blocks in a particular manner. You can, those of you who are familiar with the periodic table, you can see that it is looking like a periodic table, and the comment here is the translation at the bottom. One day maybe we will understand why Dmitri always arranges his blocks the same way. I will flash another slide talking about Mendeleev's periodic table. I will not read out the text here, but I would just like to read out the sentence in the center. Science has few other creations as well known as the periodic table. You can see this particular real periodic table. This is supposedly kept outside Bill Gates' office in Seattle, and this has real elements for the non-radioactive elements in this particular shelf. Let us now go back several centuries. Imagine that you are on this planet several centuries ago, maybe 5,000 years ago, and you do not know much about science, you do not know much about chemistry for that matter. What you see are things around you. You experience the nature, and what the ancient philosophers recognized at that time, including Indian philosophers, are 4 or 5 elements: earth, Prithvi, water, up, air, Vayu, and fire, Agni. There was another space or ether that was also introduced by several philosophers, but we will not talk about that because that has more philosophical content than scientific content. And some of these elements consisted of microscopic components with differing shapes, and that explained the various properties of elements. This is how the philosophers at that time thought about these four elements. Elements in the sense, these are not elements in the way we understand them today. But I will not talk much about that. Let us go back to the history and discover and the discovery of the different elements as a function of time. Copper, lead, carbon, silver, tin, antimony, gold, iron, mercury, even sulfur, they were known before the birth of Christ. So you can see approximate time of discovery of these. These are not very well established dates, but what you also find is that after the birth of Christ, arsenic, bismuth, zinc and phosphorus were known till 1669. But let us move forward and let us see what about gases, because air or vayu was considered to be one component, one pure substance, but the situation changed from 18th century onwards. In 1754, Joseph Black set out a way to find a cure for kidney stones, and he added acid on this chalky substance and found that a gas was coming out. So he collected the gas, and what he found is that the gas, the so called air that came from the kidney stones, it did not behave like air at all, because it extinguished a lighted candle. So he then called it a fixed air, which we now call carbon dioxide, and that was a turning point in the history of science. And this discovery of new airs continued. Cavendish identified hydrogen gas as a distinct substance, called it inflammable air. Scottish physician Daniel Rutherford discovered nitrogen by removing carbon dioxide and oxygen from air. The discovery of oxygen has an interesting history, and I do not have the time to go through the details, but Scheele, a German-Swedish chemist, he discovered oxygen in 1772, but more careful discovery was made by Priestley in 1774. He called it dephlogisticated air, but it was not clear to him at that time that it is a pure substance. Lavoisier, a French chemist, often called the father of chemistry, he in fact did a variety of experiments with this air, and he named it oxygen. And he in fact carried out a number of experiments to show that the constancy of mass when a substance undergoes chemical reaction, the total mass remains constant. In fact, in 1779, Lavoisier published a very famous book, and you may or may not be able to see this on the TV screen, but on the right hand side is a page from this book which lists elements in their old names and elements in the new names. And among others, I would like to show you that what was called air vital earlier, oxygen, he named it as oxygen. This was not initially accepted by many, but now of course we know that O2 is oxygen. Unfortunately, despite Lavoisier's contributions, he got caught in a legal problem, and he was accused of tax fraud, and he was guillotined at the young age of 50. There was an appeal to spare his life, but interestingly, you will find it very shocking that the judge said the republic, that is the French Republic, has no need of scientists or chemists. The course of justice cannot be delayed. That was a very, very unfortunate incident in the history of chemistry. I now go forward and look at the chronology of the discovery of elements. This is something that you again may not be able to see, but this particular graph shows elements which are known to the ancients, something that I showed in the first one. It also shows what are the elements that were discovered before 1700. These are arsenic, antimony, bismuth, phosphorus and zinc. So that is where we start at the bottom lower left corner, and then we move up in 1800, 1850, 1900, and it ends with Lawrencium at the top. What we notice here is that there were periods during which several elements were discovered in a row, and more so when a new analytical technique was developed. You see an analytical technique being developed and very large number of elements being discovered. Electrochemistry led to the discovery of several elements, and we will come back to that later on when we talk about Humphry Davy. Once again, spectral analysis led to the discovery of several elements. Radioactivity over here and rare earth research led to the discovery of a variety of molecules which we call now as rare earths or the lanthanides. This is another sort of a table, and I doubt if anybody would be able to read it, but here again the timeline is shown along the top, whereas the elements discovered at that time are shown by the list going down, going south. And here you will find out that there were certain periods during which a very large number of elements were discovered. I will not go into the details of this, but jump to Humphry Davy's work, because Humphry Davy, some of you may know that he worked on several other aspects of science. For example, he discovered what is called the Davy lamp, the lamp that miners use which do not lead to any explosion from accumulated methane gas. So he also is remembered for isolating using electrolysis, using electricity, several elements for the first time. For example, he discovered potassium and sodium in 1807, and subsequently calcium, strontium, barium, magnesium and boron in the following year. Although chlorine and iodine were discovered earlier, but he for the first time showed that chlorine and iodine were pure elements and not mixed with any other substance. Here I would like to take a small break and show you some experiments, because now that we have seen many metal ions, how do you detect some metal ions? And those who are in this high school, say 10th or 11th standard, you might have done the flame test. I will show you some colors and you will have to say, well, maybe in the chat box or subsequently you will have to answer this question: which element gives you the golden yellow color? On the right, I think this is very common, I am sure most of you would know. On the left there is a crimson color, and you know the fireworks that you use during Deepavali and other festivals, they all show different colors, primarily because of the presence of these specific metal ions. Let me show you three more and you try to guess these colors. On the left you see a greenish blue, on the light in the middle you see a bluish green, and on the right hand side you see a bluish color here. And these colors come from three different metal ions. Again, you can try to guess and figure out which elements they represent. Now, having discovered these many elements and gases, at that time, towards the beginning of the 19th century, chemists and scientists tried to see how these elements can be organized. You know, at your home, when you have books and papers and files and folders, you always try to keep things which are similar in a similar stack. For example, books on one place, notebooks on another place, then files and folders somewhere else. So when many elements were discovered and some of them showed properties which were similar, there was a natural attempt to group them together. And what was done initially by Dobereiner, a German scientist, he noticed that there were groups of three elements which showed very similar properties. For example, calcium, strontium, barium, chlorine, bromine, iodine, lithium, sodium, potassium. And what he found is that the one in the middle had an atomic weight or an equivalent weight which was the mean of the other two. So there was obviously some relationship among the three elements that you see in these groups of three. So this was the first step in fitting elements into a system, then account for their chemical properties and also reveal a physical relationship. A very young person, Ernst Lensen, published in 1857, which is shown at the bottom, he made 20 such triads. You know, this is a remarkable achievement for a 20-year-old young boy, and the details are not important here, but his efforts to put these many triads was again remarkable. In 1843, this was 26 years before Mendeleev's time, he showed that with improved atomic weights, because for making any of these triads you need accurate atomic weights, and these things improved, the accuracy of the atomic weights improved as we progressed through the 19th century. So with improved atomic weights, what Gmelin showed is that he made a list of triads with as many as 55 elements. And not only that, his system had gaps to indicate that there are some unknown elements. So let us zoom in on that, and here you can see, for instance, fluorine, chlorine, bromine, iodine, lithium, sodium, potassium, then the so called alkaline earth elements, magnesium, calcium, strontium and barium, and so on and so forth. So his contribution was in fact remarkable, considering that it came in 1843. Then we move to England around 1860s, and there was a gentleman named Newlands. He arranged the elements by atomic weight in rows of 7, and as you know perhaps that the English music has notes of 7. So he said that these elements represent musical notes 1 octave apart, and this became known as the Newlands law of octaves. And again at the top the letters are a little fuzzy, but let me show you at the bottom that he arranged these 7 elements like hydrogen, lithium. Remember that inert gases were not known. So the position of helium, neon, argon, krypton, xenon simply do not appear in any of them. Okay? And you notice here that lithium is given the serial number of 2, whereas actually its atomic number is 3. So this is something that we understand now, but consider that you are in 1866 with no inert gases known, and therefore you have to think about it from that perspective. Newland was very explicit that there is a periodic law. All right, now we move to another scientist, Lothar Meyer, who made an interesting and independent discovery. So in 1862, he was very young, he was just a 32-year-old chemist. He produced a table of 28 elements arranged in the order of increasing atomic weights, and he made for a book called, it's written in German, The Modern Theory of Chemistry. And here he lists elements based on their valencies, like 4 valency, 3 valency, 2, 1 and like that. On the left hand side he puts carbon, silicon, tin and lead, and he notices that carbon, nitrogen, oxygen, fluorine, sodium, and if you consider the second element, the difference in their atomic weights is about 16, 16.5, 16.96, again 16, 16, 16 and 16. So he recognized that there is clearly a pattern here. So when you try to group things together, you have to look at a pattern, whether it is round objects, triangular objects or square objects, you must be able to understand the pattern. But here we are looking at elements and their properties. So you must find ways in which these properties can be grouped together using a pattern recognition. You know, now with AI these things can be done in a matter of seconds. But consider again that we are talking about the middle of the 19th century. So he established a horizontal relationship among the elements, and he realized that the chemical properties should be given precedence and not atomic weights, because if you do with atomic weights, then you will find that there are certain elements which are grouped together but they do not have similar properties, and that necessitated producing certain gaps to indicate elements which are still not known at that time. And this was the first attempt, in fact, not by Gmelin, that he created the presence of gaps to indicate unknown elements. Now we move to the eastern part of Russia, in Siberia, where Mendeleev was born as the last child in a family of 17 children. Although his childhood was in a nice environment, but there were certain difficulties. His father contracted illness and some of the children died, and his mother had no option but to start a factory. You can read more about it in Wikipedia and other open sources, but what happened eventually is that his mother recognized that he was a gifted child. So she took Dmitri all the way from Siberia to Moscow, because she thought that a person of his caliber should study in a good university such as Moscow. But the University of Moscow did not admit him. So they again went back to St. Petersburg, because St. Petersburg is the place where Dmitri Mendeleev's father had studied. So he got admitted there, studied, and eventually he came back to St. Petersburg as a teacher in the chemistry section. This is an artist's drawing of St. Petersburg going back to the mid 19th century. In 1861-62, Mendeleev started preparing for a book on chemistry. So what he thought is that if he has to prepare a book on chemistry, he actually got the tenure in University of St. Petersburg in 1867 or so. Some of my dates may be not so accurate, but if you want to teach a course of so many elements which were known at that time, 55 were known in Mendeleev's time, you must find a way to classify them, otherwise it will become 55 different stories. So he wanted to organize it. So the first volume he completed in 1868, which had only 8 elements out of 63. So 63 were known at that time. Now in the second volume he had to create a book with 55 elements, but he realized that he must find a way to organize them. So again I will skip the one slide, but again he notices that there are certain patterns that he would observe by looking at the difference in the atomic weight between carbon and silicon, for example, which is 16, nitrogen, phosphorus 17, 16, 16. This was some of the scribbling from Mendeleev's notebooks. Again on a TV screen these numbers will not be visible, but he simply writes down, for example, sodium, fluorine, oxygen, nitrogen, carbon, beryllium, and so on. We will move forward. So what he did is that he wrote the names of these 65 known elements on the cards, on little 3x5 cards, and one element per card. And he also wrote the fundamental properties of every element on the card, including the atomic weight. And he also thought that atomic weight was important in some way, although it was not very easy to see the pattern. And then the question is, how do you group these cards and make a pattern? So this is a story, we do not know how much of it is true, but the story goes that he started moving these cards. You put the cards on a table and then you start to move them, group them together and find a pattern. And after doing it for several hours he fell asleep. And then when he woke up, he said that I was dreaming how this pattern can be recognized. And there is a story, supposedly he made this comment, I will read it out. I saw in a dream a table where all elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seem necessary. And let's see what he wrote. This is what he wrote, and this is a scribbling on his notebook. Okay. And this is in fact is the first version of the periodic table. And let's move forward, and again you notice that there are certain places where there are gaps, and this is the signature of Dmitri Mendeleev. Let's rewrite this thing in a typed format, and this is the original Mendeleev periodic table in 1869. Some of you may remember that 2019 was celebrated as the International Year of the Periodic Table, because this marked the 150 years of the Mendeleev's periodic table discovery. So this is the basis of the first periodic table. You notice here, for example, he has put question marks. You see boron, aluminum, and then question mark, carbon, silicon, question mark. So he recognized that these spaces require elements with approximate molecular weight, with approximate atomic weight, which were still not discovered. Now, this is another revised table. I will not go into these details. Those who are interested can look up, because there are as many periodic tables as you wish are available. But you know what happened is, as I mentioned in the previous sort of typed version of Mendeleev's periodic table, he put certain gaps, and he said that these are elements yet to be discovered, but they ought to have this kind of atomic weights. Now, chemists at that time were really not used to making predictions of any kind, and not to the extent that Mendeleev had in fact proposed. 4 years later, a French chemist, he discovered a new metal, and it was so soft that it melted in his hand. Okay? So, clearly it has a melting point below 37 degrees. He called it gallium, and that is the French sort of origin in the name. And it seemed to be a good fit for the empty space below aluminum, but the density did not match Mendeleev's prediction. You know, Mendeleev also predicted the density. So, he communicated this to the Frenchman. The Frenchman said that, okay, this is the density, but this is not matching. Now, Mendeleev was so confident, he wrote to the Frenchman, please redo the density measurements. Okay? He did that, and sure enough, when he rechecked, he recognized that the density of the new element which melted in his hand was very close to what Mendeleev has predicted. So, not only Mendeleev had predicted the element, but he knew the properties of the element better than the discoverer of the element. And that also found that, and he also realized that within 15 years, all the three of the detailed predictions were discovered. Okay? And that catapulted Mendeleev to made him a superstar. And these are the elements: gallium 1875, scandium 1978, this should be 1879, sorry about the typo, and germanium in 1886. And you realize that boron, aluminum, gallium, they form a triad. Similarly, carbon, silicon, germanium form another triad, and these are the two elements that Mendeleev predicted along with scandium, which were discovered at that time. So, some of the statements which have been made about Mendeleev state that he gave his table coherence by boldly revising the positions of some known elements and by leaving gaps for others as yet undiscovered. So, he was absolutely very, very bold in that sense, that he said that I must move certain elements because their properties do not match their position given by the atomic weight. Some of his predictions were not quite correct, but he scored so many positive hits that he eventually became one of the founders of modern chemistry. Now, I have another 15 minutes or so. So, what I would like to do now is to show you different versions of periodic table. In fact, if you search for periodic table, you will find hundreds if not thousands of different types of periodic table. This is one which shows which nation discovered which element. And the ones which are known to the ancients, we do not have any information about who discovered that, which country discovered that. But you notice here that United Kingdom is the top winner, at least it was the top winner when this table was prepared. This was 24 elements, United States 21, Sweden interestingly has 20, Germany 19, France 19, Russia 9, and so on and so forth. I will show you another periodic table with a slightly different version. This has the periodic table with the discovery dates in year, at least for those where the discovery was known to have been made in a certain year. This is not really very clearly visible periodic table. It indicates the abundance of the elements in Earth's crust. I will not spend much time on it, but I will show a different one which illustrates the abundance in a much nicer manner. And this is a table where on the y-axis what you see is abundance of the element per million atoms of silicon, because as you know, silicon and oxygen are the two most abundant elements on the Earth's crust. So, silicon is level at 10 to the power 6, and this is actually log scale. Okay, this is 10 to the power minus 6, minus 3, 0, that is 1, 3 and 6. So, silicon is 1. You notice here that the major industrial metals are colored in red, like aluminum, magnesium, iron, titanium, manganese, copper, zinc, nickel and so on, including lead and tungsten among the heavier elements. Okay. The precious elements are in purple, which are gold, platinum, osmium, rhodium, palladium and ruthenium, whereas the rare earth elements in blue. So, you notice here that the rare earth elements are actually not as rare as you think. They are called rare earths. They were called rare earths because it was very rare to find them in a pure form. They typically come as mixtures. They have very similar properties, so it is very hard to separate them. I will talk to you about the rare earth elements when we talk about the smartphone a little bit later. But what I would like to draw your attention to is that this yellow background indicates elements which are very, very rare, okay, but they are, most of them are very useful, and among them you see our, oops, it has moved a little bit. What I meant was to show gold here, silver here and gold here. So, silver and gold are very, very rare. Gold typically is 10 to the power minus 3 per 10 to the power 6 atom of silicon. That means if you have 1 billion atoms of silicon, you will probably find 1 atom of gold. So, it is that rare, and that is what makes it so expensive. The periodic table as in 2019 has 118 elements. Perhaps you know that this element was named OG finally by IUPAC in 2016, and I would also like to draw your attention to element 101, which is named after Mendeleev. Now, last 10 minutes or so, I would like to connect periodic table to us, to human beings, our activities. You have seen so far how certain elements were discovered, how certain gases were discovered, how different people try to group them together. Now, let us see how periodic table connects to us. And I would like to start with this provocative statement: the periodic table is in us. Now, let us look at the composition of elements on the Earth's crust. I am only talking about the Earth's crust, not the atmosphere, versus humans. The major element is oxygen, followed by silicon, and you see these metals, aluminum, iron, calcium, sodium, magnesium are also present on the Earth's crust in good amounts, and also potassium and titanium, but there is very little hydrogen. The hydrogen is present only in the form of moisture. Now, let us compare that with the human body. Human body has much more oxygen, 61% oxygen, and you notice where the Earth's crust is silicon, the human body is carbon 23%. There is practically no silicon in the human body. Hydrogen is 10%, nitrogen 2.6, calcium is 1.4, phosphorus is 1, and all other elements are much small in quantities, but then they play very important roles, and I will come back to that in one of the next slides. So, these 6 elements, carbon, oxygen, hydrogen, nitrogen, phosphorus and sulfur, they comprise more than 98% of the human body, and most of it is present in the form of carbohydrates, nucleic acids, DNA and RNA, proteins, hormones and vitamins. There has been many theories that how life evolved, and most people believe that life evolved from the sea in the form of very primitive organisms such as bacteria or something similar to that. Now, I would like to show you how the metals are distributed in seawater versus how they are present in human plasma, and then you will realize that even though the metals are present in a certain concentration, during the process of life formation and evolution, many metals were chosen which are in fact very rare in the seawater. For example, in the seawater, the amount of iron, this is multiplied by 10 to the power 8, okay. So, this is present in a very low concentration, but in our human plasma, as you know, red blood cells contain iron in the form of hemoglobin. So, the plasma to sea ratio is 400,000. Similarly, zinc copper, molybdenum, these are present in very small amounts in the sea. So, there must have been a selection process by which from the bacteria to larger animals to human beings, these elements got concentrated because of their effectiveness in supporting our life system. Elements of the human body, if we look at the periodic table and color these elements of the human body, you see that they are shown with different colors, and most of these elements are found, at least the ones which are shown in the first 4 colors are present in significant amounts. The others may be present, but the ones which are present in very small amounts, it is not clear whether this is because of any function or is it because of any environmental issue. The elements of life actually are limited to about 28. The ones which are shown in green, like hydrogen, sodium, magnesium, calcium and potassium, and of course carbon, nitrogen, oxygen, phosphorus, sulfur and chlorine, these are the bulk biological elements present in a larger quantity in our body, whereas the ones which are shown in the pinkish color over here, they are essential for bacteria, plants and animals. The ones which are shown in light blue or cyan color, they are probably essential, but their roles are still not known. Maybe some of you will discover what roles they play in the biological systems. I would also like to highlight the essential trace elements in our body. For example, iron, zinc, copper, these are present in fairly large amounts. I have indicated the amounts. For example, 4 grams per male, 3.5 grams per female, because the females have slightly lower hemoglobin content in the blood. Copper, surprisingly, is present in a fairly large amount in a human body, in an adult human. So, similarly, manganese, selenium, iodine, vanadium, cobalt are present in different concentrations. Cobalt is the minimum 1 milligram in a human body, but 85% is vitamin B12 or cobalamin. Okay, so from the human body we go to 2 of the most useful things in our life. One is a vehicle, okay, motorized vehicle, and you see here a periodic table of vehicle elements. The ones which are present in constructing a vehicle, this includes vehicle elements which are used in the construction process. Maybe not all of them are present in the vehicle when you are driving, but they are listed here. Okay. And last but not the least is the elements of a smartphone. There are something like 45 elements in the smartphone, and as I mentioned earlier, that screen and electronics, they contain a fairly large number of lanthanides. And let me show you here, the screen contains lanthanum, terbium, dysprosium, europium, praseodymium and gadolinium, whereas the electronics contain also several rare earth elements. The casing that you see contains carbon, magnesium, bromine and nickel, whereas the battery of course contains lithium ion battery, which contains lithium and cobalt among many others. But one point that I would like to mention here is that the endangered elements to make mobile phones are running out quickly, and therefore you need to be very, very careful. Now I have a small periodic table related song to play, so for which I think I will quickly go fast. And this is a picture that I must show. This is Mendeleev's study in the museum at the University of St. Petersburg, and Professor Pradeep K. Ghosh, who visited St. Petersburg University, he took this picture and shared with me. So I must thank him for this picture. I will very quickly highlight this particular website called isotopesmatter.org, which was published by IUPAC in 2016, and I would like you to go through this one. Here is another one. The one link shown on the bottom left is for young children, and if you click on the periodic table you will find where some of these elements are present, whereas the link shown on the bottom right over here is for the slightly older children, maybe 11 and 12, where you will find properties of these elements as you go along. Here is a spiral form of periodic table, but I think we do not have time for go through all of that, but I would like to play a small periodic table song which was created by a Harvard University mathematics professor, Tom Lehrer, in 1950s. And let me show you one with an animation. You will find it in the link shown at the top. at the bottom, the first one, whereas the one on the bottom is a song sung by Professor Lehrer himself. So let's enjoy the music, and as the last.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendeleevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.
Viewers, I hope that you have enjoyed the music and also the topics that we discussed earlier about the periodic table and how it evolved as a function of time. So to end, I would like to thank all of you for listening to the talk, and last but not the least, thank you NCERT for giving me an opportunity to share with you some exciting stories about elements and the periodic table. Thank you very much.
Thank you, Professor Maitra. खत्म हो गया, लग नहीं रहा, इच्छा है और सुने, because I was enjoying these anecdotes which you shared with us. Sir, there are many questions which we are receiving.
Sure.
But at the same time, we are having our own questions too.
Absolutely.
सर, सबसे पहले बात तो मैं सपनों की करूँगा. सपने देखना हमारा काम है, और ख़ास तौर से विज्ञान का विद्यार्थी, साइंस स्टूडेंट तो आँख खोल करके सपने देखता है. So as you do, I know. One thing I must say, viewers, see, you are seeing a great teacher today. You might have noticed Professor Maitra during his discussion given many open threads, where he said that probably in the days to come you can explore the properties, you can find out, you can discover more elements, and so far so on. This is a great teacher who always talks about the dynamicity of the subject as well, and motivates children to pursue their careers in fundamental sciences. Great, thank you, sir.
Thank you.
I am touched.
Thank you very much.
Touched with this gratitude, with this. I am really touched.
Thank you very much.
Thank you, sir.
Thank you.
1868, 63 elements. Next edition of Mendeleev's book, 65 elements. Up till 1998, nearly 98 elements. 114, somewhere around 2000, and now 118.
Yes.
Now 118. Dil mange more. कहाँ तक पहुँचेगी? Because why I am saying dil mange more? Because the kind of properties which we try to see in the materials, whether composite materials or man-made materials or naturally abundant materials, are often not seen. One great challenge is that the materials which are naturally abundant today are good thermal conductors, largely good thermal conductors as well as a good electrical conductors, but for several applications we want a good thermal conductor should not be a good electrical conductor, or
Correct.
vice versa.
Correct.
So, I mean, this makes us to explore more. Number one, is there any scope of finding more number of elements found naturally on this planet, or have we discovered some other kind of elements on other celestial bodies? Sir, these are the two questions.
So based on what we now understand about the stability of the nuclei, you would notice that most of the elements, sort of post-transuranic elements, particularly those beyond 100 or 105, they have very limited stability. In fact, many of these elements were made by nuclear bombardment, nuclear processes, just a few atoms, and from that the properties were inferred. It is partly because as the atomic number increases, there is increasing proton-proton repulsion, and there is some sort of a stability region, and some of these elements beyond 110 are going outside of the stability region. So there is some doubt among physicists whether more elements can be discovered, but then there are also some reports which say that perhaps not in the sequential manner, but there are certain magic numbers. I believe it is somewhere around 130 something, 134, which may show an unusual stability. Now, so far I think the physicists have obviously not stopped at 118. So they are trying to push the boundary, because that's how science advances.
Grows, yes.
But whether it will be found and whether it will be available in substantial quantities where you can actually do things with it, that remains a big question. But I must say to the audience that, you know, we talked about element 95. I hope you remember what it is. Americium. Americium 241 in fact is used in the smoke alarms that is in your house. So using neutron bombardment of plutonium, americium is made, only a few grams every year, but each of these smoke alarms contain a very minute quantity of americium,
yes,
for detecting the smoke.
Yes, yes. So, I mean, yes, we know, sir, that there are many elements which were framed or which were made artificially in the laboratories first, and then they were found naturally also in very small quantities.
Right.
Are we really searching for new elements, and can you tell us some institutes where our children can approach if they want to pursue further in this area?
I think the discovery of the super heavy elements has become more of a physicist's area, and this requires very, very high energy systems, beams, and these are not available in most places and certainly not in India. I don't think in India we have any very serious equipment of this type which can provide such high energy collisions. So there are places in, for example, in CERN in Switzerland,
CERN is the CERN
in Germany, and
Lawrence Livermore,
LBL, Lawrence Berkeley Livermore Lab, and perhaps some places in Russia where they are pursuing. And I think this has become a multi-institutional, multi-disciplinary project, but largely involving high energy physicists.
Right. And so, when I was in school, I remember, rather cramming the periodic table, like hydrogen, helium, lithium, beryllium, and so on. So, was hydrogen discovered first?
Hydrogen, of course, was called the inflammable air.
Yeah.
That was not discovered first, because as you have seen, that the amount of hydrogen in the Earth's crust is very small. It doesn't appear in nature.
Yes.
I think only after electrolysis was established, then people started electrolyzing and discovered the hydrogen gas.
Right. Probably the copper was the first one, 9,000
Copper was
BC.
8,000 BC.
Yes.
Yeah, but so those will be plus or minus several hundred years.
Yes, of course, when we talk about plus
correct.
minus under root n will follow here as well.
And you said, sir, it's a big question, what more kind of elements will be discovered and where. But abhi tak jitne bhi discovery hui hai, is there any pattern in their geographical location or in their abundance jahan wo mile hain?
Yes, in fact, there are certain elements, because it all depends upon how the Earth's crust cooled, because sometimes the cooling process concentrated certain ores in a certain region.
Yes.
So because of the different terrains, I mean, I am not a geophysicist or a geologist, but they are probably the best people to answer this question. But I believe that the concentration happens because of certain intrinsic localization during the cooling process of the Earth and the geological features. For example, we don't have much of lanthanides.
Right.
Okay, we do have some along the coast of Kerala in the monazite sand. So we have an Indian Rare Earths Limited.
Right.
But for example, we don't seem to have much of lithium in the country, but Chile, certain regions in China, they have larger quantities of lithium. Okay. There was a news item that in certain places in Kashmir, they have found lithium, but I think it is still not commercially exploitable viable, quantity. We have to wait and see.
Yes, I remember that.
I have many other questions. Probably this can continue for 1 more hour.
Yes.
We'll have one more time, but now we have to wind it up, sir. Sorry that we are not able to do it.
Problem.
Once again, I thank you very much for being with us. We would like to have you another time, for having more questions, probably in the question answer session only.
Thank you
directly, sir.
Thank you very much.
So can we go for the next?
Absolutely, and it was a delightful journey with you, sir, and you ended it on a musical note. Thank you so much, sir, for your contribution to the session. And I would also like to thank the brain behind the session. Thank you so much, sir, Gagan, sir, for your contribution to the session and for bringing such topics and such eminent personalities to the studio.
Harpreet, the point where you wind up this today's session with the geophysicist and this, we are going to have Irfan Mandal, who is going to talk about the coral reefs, islands, and all this. We are seeking. We look forward listening to him, and then we are going to have Anil Gupta from Kharagpur. So probably they will be able to answer those questions little better.
Sure,
probably. So friends, we are with your suggestions, we are bringing more and more sessions, more and more exciting sessions to this series. So next one is
Sure. So we are looking forward to these sessions or previous sessions. अगर आप देखना चाहते हैं, we have a website for that, and that is ncert.nic.in/webinar_series.php. यहाँ पर आप सारे previous sessions देख सकते हैं. So friends and viewers, that was our wonderful discussion today on the topic It is Elementary, a story of elements and the periodic table. That was the 85th edition of this wonderful journey, and with this it's a wrap. Once again, I'm thanking both my guests. And yes, sir.
Before that, we have to speak about the next session. Next week, friends, we are coming back to you again on 20th of September at the same time, 10 o'clock. We are going to have Abhay Fulke with us. He is from the CSIR NIO, National Institute of Oceanography. He will be speaking on oceanography, pollution and its solutions. He will be with us. We are going to have, in days to come, we are going to have more sessions on oceans, maritime histories, maritime boundaries, etc., etc. So we look forward listening and having you again on September 20th here Friday.
Yes, indeed.
Thank you.
Yes, indeed. And with that, it's a wrap. This is me, Harpreet Kaur, taking leave of you from this wonderful session, and I'll see you very soon. Namaskar.